So lesson 6-7, similar figures. Similar figures have a couple of things that constitute the fact that they're similar. One is they have to have congruent angles. Oops. They have to have congruent angles, and they have to have proportional sides. That's why it's in chapter 6, because we've been talking about proportion. So let's talk about the congruent angles first. A little bit easier and quicker. One thing I want you to notice about these two parallelograms are the arcs at the angles. In the first parallelogram, angle N has one arc, and so does angle P. If they have the matching number of arcs, that means they're the same measure. Notice in the larger parallelogram, angle D and angle B also have the same number of arcs. And since they're in the same picture, that means they are the same measure all the way through that problem. So angle P is 70. It asks right here, what is the measure? That's what the little m means. The measure of angle D would be what? Anybody know? If angle P is 70 with one arc, what would the measure of angle D? It would have to be 70 degrees as well. Notice that M has two arcs, O has two arcs, A has two arcs, and C has two arcs. That means they're all the same. What would the measure of angle M be, Dakota? 110, because it matches angle A. So in similar figures, the angles are congruent, that match up, the ones that are in the same spots. Okay, they're called corresponding. Now, let's look at the proportional side part. You will be writing proportions on all of these today, and you can do this a lot of different ways. Remember how I've had you write kind of a note in front, the two things you're comparing? Well, when you're comparing similar figures, you could do it like this. You could do small over big, big over small, left to right, right to left, however you want to do it so that you make sure that you get the numbers in the right spot. I'll be honest, here's what I almost always do. Small to big. I put that out in front, and then I set up where I'm going to write my proportion. So fraction bar, equal sign, fraction bar. All right, now, since I have small on the top, let's look at the one that's the smaller parallelogram. So this one over here. Give me a side that is marked from the small parallelogram. Okay, anybody see one? Braxton?
P.
What is it?
P.
The side lengths, not the angles. P is an angle, so the side lengths. 3. So 3 from the small parallelogram matches what length from the big parallelogram, Cece? 12. Okay. We need to look for one more side from the small one, Shane. Yeah, that's the one we're looking for anyway, X. And X matches what, Stephen?
33.
33. Okay, so once you get all 4 spots filled in, and my 33 didn't finish, I've got it here, there it is. Once you get all 4 spots filled in, you do what we've done all week. Cross, cross. So you're going to show 12 times X equals 3 times 33. So 12x equals 99. And divide by 12. You divide the last step. X equals. Okay, so if I do 8 times 12, that is 96. So 8 and 3/12, so 1/4. So 8.25 is what you would say. If they are labeled with units, you should put a unit, but that one is not. So you would just say 8.25. No, it's the length of the side. Only the angle measures do you put the degree symbol on, but not the length of the side. Those might have feet or inches or centimeters or something like that, but this particular one doesn't, so you wouldn't put anything. All right, any questions about that? Okay, let's talk about what I've got written right over here, the 3 angles of a triangle. That was a note that I wrote in there for myself. Who can tell me the measures of the 3 angles of a triangle? What do they add up to? Dakota? Yeah, so be aware, 180 degrees. You may need to know that. If it gives you 2 measures, how could you find the third one? If they give you 2 measures in a triangle, how do you find the third one, Tori? Yeah, you add them up and you subtract from 180. So that could happen in an example or a problem. If they are similar, remember the matching angles are equal. So they might use the fact that 3 angles add up to 180 and that they're similar to ask some questions about angles. Okay, so this diagram that we have, do you see 2 triangles in it? Hopefully you do. Do you see? One is completely inside of the other, right? Okay, so again, I want to find the x, which is this. Looks like it's the right side of the smaller triangle. I'm going to set this up exactly the same way. I'm going to say small to big. That always helps me. Fraction bar equals sign fraction bar. So let's do this again. Give me the length of a side in the small triangle. Trayton. X. X from the small triangle matches what from the big triangle? 20. Give me another measurement from the small triangle. 10. And what does it match from the big triangle? Cece? 14. Anybody have any questions how we filled those in? That small to big really helps me to figure out what goes where. Okay, we're going to cross, so 14x equals 20 times 10. And 14x equals 200. What's my last step always? Shane? Divides. We're going to divide by 14. And this point I would let you use a calculator. So I'm going to go over here because I don't have space on the right.